All right. Well, good morning, everyone, and thank you for coming. And I want to welcome Siobhan Kassem to give our presentation today. So, Siobhan is a native of San Diego, California, and holds a bachelor's degree in chemistry from California Polytech State University, San Luis Obispo. That's a long name. And a master's of science in oceanography from Texas A&M University. Her graduate research focused on the aragonite saturation horizon within the North Pacific. And today she will present her key takeaways from the Wepal-Quasimeme Workshop, which took place in March in the UK. This workshop addressed analytical practices in carbonate chemistry and the specific regional requirements of Europe. We are pleased to have Siobhan share her insights on this important topic. So, thank you, Siobhan.
Awesome. Thanks, Bob. Yeah, I'm sharing what I learned at the Wepal-Quasimeme Workshop. And so first, what was the purpose of this workshop? And it was to bring together carbonate chemists from multiple labs and countries to discuss key points such as intercalibration testing, CRM regional concerns, practices for sampling, preservation, storage, and analysis, and then new instruments and sensors. So in today's webinar, we're going to look at what is Wepal-Quasimeme and then touch on some of those key workshop topics such as proficiency testing, reference materials, MCP, instrumentation, and we'll finish up with international collaboration. So what is Wepal-Quasimeme? Both were first distinct and separate groups that focused on the terrestrial and the marine environment, but have since joined together to conduct a wide range of analytical in environmental tests. And some things that this group does is provide reference materials for interlaboratory comparisons, evaluate lab performance for both that marine and terrestrial environment, and then support quality assurance and method validation, specifically through organizing proficiency testing. So we'll look at that next. Proficiency testing, or also called interlaboratory comparison, is used to determine the performance of individual labs for specific tests or measurements that they would do in their labs. And it can also be used to monitor the lab's continuing performance over time based on their continued participation in these proficiency tests. So these work by having multiple labs being involved in one proficiency test. Each lab measures the same testing material or sample with whatever method they currently have in their lab. And then those labs are going to give the data that they measured to the test organizer. So in this case, Wepal-Quasimeme. And then at the end of that testing period, the organizers compare the measured results and analyze the spread of that data. Specifically, we're going to look at AQ15, or the Ocean Acidification Proficiency Test, sponsored by Wepal-Quasimeme. Again, its purpose is to validate internal lab quality assurance, and this is done by giving all participating labs the same testing material, but now specifically it is seawater from Eastern Atlantic or the Baltic Sea. And then those labs can use whatever methods they so choose, and then report back the measurements of both DIC and TA. At the end of that testing period, each participating lab will receive a testing report at the end of the time frame that has a performance assessment. In this, there's a statistical evaluation to see how that lab performed compared to the other labs that also participated in this proficiency test. And they do this based on what's called a Z-score, which I will talk about next. And again, the importance of proficiency testing is because global data sets rely on consistency to ensure measurement quality. But currently, there's only one US lab that is participating in this AQ15 test, so they're looking for more participation given the uncertainty of reference materials in the long term. And so now touching back on Z scores, again, these are used to assess how the lab performs compared and how closely to the other participating labs. So here we have a graph on the right-hand side showing a lab code on the y-axis, which is for each participating lab. On the upper and lower x-axes are the z-scores that range from -6 to 6. And you can see 4 bars all varied in color representing the 4 samples or testing material that each lab was given to measure in this proficiency test. And then the length of these bars shows the z-score for that sample. And a z-score that is less than 2 shows that that sample is within acceptable limits of the consensus value of the proficiency test, again, for that sample. But if you have a z-score in between 2 or 3, this means that that value is borderline and perhaps not very close to the consensus value, so your methods may need review to understand if there's any gaps to lead in the discrepancies of measured values. Or if you have a z-score greater than 3, that means that that sample measurement deviated significantly from the consensus value, and your method should require investigation to see what may have went wrong. And these performance assessments do not indicate why your lab may have gotten a poor z-score, but it's up to you to go from start to finish to see where are any gaps that may have gone wrong. And then again, more participants would improve the precision of this consensus value that the z-scores are based from, which would make them more reliable for assessing lab performance. Other benefits of proficiency testing are that, again, it's that internal lab quality assurance. You can have improvements of your methodologies if you do these tests to understand all of the steps that you take in your lab for these measurements. And they also offer additional testing material in addition to certified reference materials to further have quality assurance for this monitoring data. And so now for reference materials. Currently, Andrew Dixon's lab at Scripps is the best and only group producing these large quantities of reliable reference materials, or CRMs, certified reference materials. But there are some issues with this, in that Dixon's group is largely carrying this load alone. The CRMs also span a quite narrow salinity concentration range, which may not be optimal for samples outside of the Pacific. And members at this workshop working in the Mediterranean and Baltic Sea saw this as their key issue. And then last, some countries ban the use of mercuric chloride, so there is a need for alternate testing material that would be inclusive to these countries, so that they can also contribute in producing carbonate chemistry research. So Wepal-Quasimeme's proficiency testing material does hit at some of these issues with CRMs and shows to be a benefit as an added testing material. So here we have a table of both CRMs and testing material with a few characteristics. Starting from the bottom up, we can see that the testing material seawater type is much broader than the seawater type found at the CRMs. This results in, again, that broader concentration range that was one of the main concerns of the use of CRMs. And then next, the preservation or conservation technique that Wepal-Quasimeme found to work best was sterile filtration, but this resulted in a lower shelf life of 6 months compared to the longer shelf life of tens of years of the CRMs. And again, these proficiency tests are looking for more participants to narrow down the consensus value, since that is what's being used to determine the concentration of these samples. So here we have an exaggerated map showing how San Diego, or Scripps, is that large and main producer of certified reference materials worldwide. And this sparked the conversation at the workshop for the need of perhaps a European reference material hubs, or just a couple regional reference material hubs. Now in the bottom corner, there are 3 distinct hubs, and there are some advantages and disadvantages that are needed to be considered. One is that an advantage would be that these hubs could cross-check each other to ensure their methods and values are consistent and correct so that we are producing accurate data. You also have the advantage of backup hubs. If one hub goes down for some reason, then the other hubs can help to pick up that loss and further supply reference materials. And then next, one of the key advantages brought up at the workshop was the need for shorter transportation of these CRMs, or just reference materials in general. This shorter transportation would also equate to lower shipping costs that would be beneficial to newer labs who are just trying to get into carbonate chemistry research. And then last, again, these regional hubs can adjust to regional needs, meaning that they can source water within their region where a lot of the participants of that region are conducting research. But some disadvantages or speed bumps is that it's hard to reproduce the methodologies of the CRMs at Scripps. And then, of course, a lack of funds really halts any growth for any field. So a lack of funds puts the regional hubs at a halt. And so there were multiple labs at the workshop that are looking for partners for collaboration as to how to best tackle this problem. There was one idea at the workshop that was brought up, as shown here on the slide. On the left-hand side, we see a certification and a batch production and logistics site, as shown by the yellow and the red mixed dot. And then you also have a network of water sourcing stations. On the right-hand side, again, you have that centralized certification facility with that network of producers along with that network of water sourcing stations. And both of these ideas could also be implemented as well in the States as we look forward to the long-term trends of certified reference material production. Then there's the topic of infrastructure availability, and now specifically in a proposed European hub. There are research institutions available to contribute to this reference material production, with some national meteorology institutes available to handle certification tasks, but some outside organizations that are interested need clear and sustainable long-term plans before they're willing to get involved. And so I encourage you to reach out to your European colleagues, or if you also do research in these different regional hubs, to see how you can best support them, and then see what their current plans are for reference materials or any issues they currently have, to see how you can also best support them. So now we're going to shift gears and talk about MCP in these 3 points. First, what is MCP, to make sure we're all on the same page, and then we'll look at the purity, standardization, and next steps that were proposed at the workshop. So first, what is MCP? I found this neat video from Moat Florida Keys Coral Reef Lab, and this shows how MCP is a dye used in spectrophotometric pH measurements, and this dye is used since it works best in the pH range that aligns with typical oceanic conditions. But why is MCP important for pH, and why do we have to have an accurate pH measurement? And so we know it's to ensure the monitoring of ocean acidification and to support these global climate models, because even a small change or a difference in pH can have a significant and ecological effect, especially on calcifying organisms. But there's a key challenge with MCP in that the variability of the purity of this dye leads to inconsistencies in pH measurements. So most vendors sell unpurified MCP, but this contains impurities that affect the absorbance spectra that is needed for the calculation of pH. Whereas purified MCP is typically sourced from labs, but is not commercially available. And again, the problems with the impurities within the MCP is that it distorts the absorbance at the 434 wavelength, which leads to the incorrect pH values unless corrected for using lot-specific factors. So one lab at the workshop in particular posed their thoughts on the 3 what's needed next steps with the use of MCP, and proposed some collaboration for their next goal moving forward. And they noted that there's a need for a universal correction protocol that works for any manufacturer of dye, and then a consensus on pH SOPs in oceanographic communities, since they saw a discrepancy in data based off of methods, and a consensus on a pH SOP would support collaboration over labs or even countries. And then last, a development of some sort of reference material or a calibration method that can also be used across labs. And so the goal that they proposed to move forward was to develop that correction for both pure and unpure dye in any manufacturer of dye, so that historical and current data sets can be more consistent. And so they emphasize a need for collaborators on this project. So if you have any ideas with how to improve this side of our research, I encourage you to reach out to Marta. And now we'll shift gears again and look at instrumentation. So we had some companies and labs share advancements on improving instrumentation and seawater carbonate chemistry measurements. And as we know, we rely on these accurate measurements to detect even a small shift in pH or other carbonate chemistry parameters, because this is critical for tracking ocean acidification and its impacts on marine ecosystems, which then can support climate models and policy decisions. So first we'll look at Scalar. Scalar was a company that walked us through the instrument that they had at NOC, or again, that National Oceanography Center in Southampton. On their website, Scalar has a large range of instruments that a lot are customizable to the specific needs of your lab. So the one that I saw, as you can see in this bottom image here, had DOC, pH, TA, and DIC, and then one sample could be used for all 4 parameters. The samples for this specific instrument that I saw were these 40 milliliter glass vials with a septum on top, and each sample takes about 100 seconds, followed by a wash time of 60 seconds, which would lead to around 30 samples per hour. But again, there are many different types of scalar instrumentation that can be tailored to the specific needs of your lab. And now we'll move on to Lab on Chip. Lab on Chip is an in-house instrument being made at NOC, led by Socrates. And these lab-on-chip sensors are in situ pH, TA, and DIC sensors. They are composed of, as you can see on the left-hand side, this microfluid chip that is specific to what you want to measure. And so all of the different housings or the holes or microtubing within that microchip would be specific to, let's say, TA or DIC. And then on top of that microfluid chip would be a power board that does all of the calculations for the specific parameter that you are measuring. Here's some data that I grabbed from their official website for the instrumentation, but they did not have any on TA. And then here is an image and a video showing the components of this lab-on-chip sensor. So first, this image on the top right corner just shows this top part, or as I call it, the head of this lab-on-chip sensor. And on top of it, there are bags of reagents, reference materials, or dyes that are specifically needed for that parameter that is being measured. And now this video shows how those bags fit within the housing of the instrument. And so right now, both the head and the body of this lab-on-chip sensor aren't being used, so they are taken apart just for storage and cleaning. And then there's also no internal battery needed for these sensors, but instead can connect to a glider, mooring, or CTD that it is deployed with. Not shown here, but there are also pressure stable resistant walls filled with oil so that these instruments can be deployed for the full water column depth. And the deployment time for these instruments are dependent on the amount of reference material needed. So on average, this is about a year. And since these instruments are made in-house, they also have a certain amount of customization that is available for each instrument that is being made. So I encourage you to reach out if this is something that you would like to have. Oops. Then here is some data of this lab-on-chip sensor deployed in an estuary. Here we have total alkalinity on the left-hand y-axis. We have time on the x with salinity on the right-hand x-axis. These blue data points represent the data from this lab-on-chip TA sensor. The yellow data is salinity, with these black crosses showing discrete bottle samples that were also taken, which you can see lie on or near the lab-on-chip sensor data. So further work has been done using these lab-on-chip sensors within the Celtic Sea, but that work is currently in review. Then next, I want to talk about CO2 sys. Even though it's not technically an instrument, it fits into this part of the talk. So if you don't know, CO2 sys is a program that uses pairs of measured parameters to compute the rest of the marine carbonate system. And so this image here shows all of the intricacies that are needed for measurements within the marine carbonate system. And this program is available in multiple versions, such as MATLAB, Excel, and Python. This program is important because it supports analysis of data from multiple different sources, including field measurements, lab experiments, and autonomous sensors. Specifically, I want to focus on the Python version of CO2 sys, or also called PyCO2 sys. So Dr. Matthew Humphreys at the workshop showed his newest updates for PyCO2 sys within version 2. And the key updates that he wanted to share was that this version is faster, has lower memory overhead, and has a validity checker to ensure whether all parameters are within their valid ranges. There are also two add-on packages to determine both TA and DIC from the instruments in which they are measured from. So if you use the Python version of CO2sys and you want more information on this new version, I again encourage you to reach out to Matthew Humphreys. And then last, I want to finish up on international collaboration. The key point or key issue that was brought up at the workshop was the need for better vocabulary and reduced redundancy in the current vocabulary to support collaboration over countries and languages. And so two main ways that they saw this could be done would be to map words that are used for the same topic. And then this would ensure that data is available with standardized vocabularies or that available key or map to ensure the understanding across languages. And then last, there's a need for agreement on data and metadata by data centers and data type to again further support collaboration from country to country. And that is all that I have for you all. But I want to thank both Shin-Ping Hu and Jen Vreeland, who supported and encouraged and helped me get to this workshop. And I want to thank all of the Wepal-Quasimeme participants and coordinators who made this workshop go smoothly. And with that, I'll take any questions. Thank you.
Thank you, Siobhan. Yeah, if anybody has any questions, everybody's muted, so make sure you unmute if you have a question or raise your hand. All right. Kim?
Hi, Siobhan. Thank you so much for your presentation. This was a really fantastic overview. I have a question about the AQ15 OA proficiency testing at Wepal. And my question is, do you know, well, two questions. How many different methods were used to determine the consensus value for the Z-scores for sort of grading the other labs? And then the other one is, I wonder, if enough participants were participating in that, using a variety of different methods, if it would be beneficial to create a consensus score based on method used to maybe try to generate more accuracy in the grading results?
Yeah, I mean, that's a great point. I think one of the reasons they don't say which method is best or not is to allow for those perhaps more startup labs to have some of the cheaper instrumentation to also find their own data. But I think there were three categories of instrumentation, but the categories I don't recall right now, but they were whether it was an open cell, closed cell for TA, and then I believe one other vague group, and then in those groupings were subgroups of the different methods that were used. But yeah, that's a great point, and I'm not sure the specifics, but yeah.
Thanks again, really appreciate it.
Thanks.
All right, Emily Hall, you have a question?
Yeah, hi Siobhan, nice to hear your voice again. Quick question on those couple of instruments that you talked about. I think one of them is the lab on chip, and I cannot remember the other one. Just curious about price and availability, and if these are instruments that are developed, far enough along in the development that they're, looking to sell worldwide or whatever,
Right.
considering we have a shortage of other instruments that
Yeah.
we're using. I mean, aside from precision and accuracy, just wondering where along the steps they are with those.
Yeah. So Scalar is, I think, ready to ship and help and, set up labs. The price, I'm not too sure because each system is tailored to the lab and what they want to measure. And so I can assume there's base rate, but that will, go up or down based on the needs of the lab. And there are different sizes of the instruments themselves. And so I recall at the workshop, I think I looked at what they called a medium sized of this, um, the DOC, PHTA, and DIC, but they also have ones that have less room for samples. So I assume that's cheaper. But I'm assuming you may have to dig to see what your need is and then what they have. But for the lab on chip, I know that they were looking at a production team to be able to sell those lab on chips, but they noted that it's more expensive to go through the production route. And so they're open for direct like chats with labs who want to use their lab on chips, and they are open to building those. I'm not sure what the cost would be for that either, since they are tailored again to the labs, which is a huge pro of both this lab on chip and Scalar, but it just doesn't lead to a perfect price point. But I think maybe 10,000 was for the lab on chip that I can recall. Thanks.
All right, thank you.
Yeah.
Thanks, Emily. Xianping?
Great, Siobhan. Thank you for the presentation. It's a very nice summary of the workshop. Okay, I have a couple questions on the proficiency tests. So how, because last decade, NOAA OEP organized 2 rounds of data quality. I mean, send us the blind samples to measure, but then we haven't had any this decade. So if the lab here in the US wants to participate this test, do you know the process? And do you know also how often they organize this?
Yeah, great point. So for that, they said that they have either 1 or 2 rounds per year. One round is 550 euros, but 2 rounds is 725. And I think on the first slide, I can try to go back to it. Excuse all the tabs, but there's an email in the bottom corner with the lead of organizing these tests. So I would say to reach out to Celia and check out this website here to look at the steps.
That's great. Actually, what if people just use, for example, use one batch of the CRM to calibrate instruments? Because even though Andrew Dixon doesn't like the word calibration.
Yeah.
What if we use one set to as the standard, the other we just pretend we don't know the concentration and use that as a proficiency test material? Would that work?
I think so, but one of the key aspects of the proficiency test is, again, as you said, you don't know the value of that, and there could be a bias where if your lab measures open ocean water, your instruments may be tuned to those high salinity values. But for the proficiency tests, since some are taken in the Baltic Sea, then you can get a testing material that has low salinity to check your methods and see if your instrument is biased towards those open ocean type samples. So I think that is a pro of not CRM, but I think you also could if you wanted to.
Okay, great, thank you.
Thank you.
All right, well, thank you all for coming, and thank you, Siobhan, for presenting. If there's no more questions, then we can end it here.
Awesome. Thank you very much.
Thank you all.